when projectile is thrown at an angle, say theta, right, with respect to x. So that we will try to find out. So suppose this is the surface of Earth, and now in this case we have thrown a body within a velocity, initial velocity u, or projectile. So what is the initial velocity along x-axis? That if is thrown at an angle theta with respect to x-axis, so that ux would be u cos theta, right? This direction, this u would have a component u cos theta, and here in this case uy would be u sin theta. So after reaching some point, suppose P, it had a distance x and y, so that is the distance, suppose is x, and this suppose is a distance of y, right? And after reaching to the highest point, now it try to go or replicate its previous half path. So after this it will strike at some point at the surface of Earth at a distance, at some distance, suppose that distance is again is r, which is the range of the projectile. That we will try to find out, and this is the maximum height, which suppose here in this case is h. So suppose what is the point at point P, what is the distance? We know what is the distance here is, because s is equal to ut plus half at square. So what is the point here x here? So horizontal distance क्या होना चाहिए? What is the horizontal distance here? At certain time, suppose that certain time t is t, and horizontal distance suppose is x. So that in place of s you can write x, and velocity here is ux, t plus half ax and t square. Again ax is 0 because nothing is being added here, no engine, nothing, no fuel. So ax is 0, only there is an acceleration because of gravity of Earth, which is y, which is minus g. So ax here is 0. So ux is what? Ux already is given, u cos theta, right? And t here is t, x is x. So what is t here is then x divided by u cos theta. Okay. Similarly, vertical distance. So vertical distance is what? Vertical distance would be, again you will put here y, because that is the distance is traveled, and it is going upward right now. Okay, so that would be plus y, and uy into t plus half ay into t square. Here in this case ay is minus g, that we know. And what is uy? Uy also we know. So uy is u sin theta, and t is suppose is t plus half, and here ay is minus g into t square, and that we know y is something like that, u sin theta. If you put this value t from here, that would be u x divided by u cos theta minus half g. Put the value of t from here, suppose this is the equation 1, so that would be x divided by u cos theta square. So that would be u would be cancelled here, so that would be x tan theta, sin by cos theta is tan theta minus half g x square upon u square cos square theta. So this is the equation. This is also a parabola, right? So this then is the equation of parabola. So you can write this is an equation of a parabola. So now we will try to find out what is the maximum height that it can attain, right? So maximum height attained by the parabola, by the projectile, sorry. So that basically is the projectile. So the maximum height, suppose this projectile is thrown from a point O here with a velocity u, and horizontal velocity is u cos theta, of course, and that is the theta, and that is ux, and here is uy is the vertical, which is u sin theta is the velocity, and it travels and then goes down like this. So after reaching some point here, suppose here there is a maximum height that it can attain. So here you will notice that from point O to point this, okay, and that suppose the maximum height, suppose this is the M point, maximum height for M for maximum. So before come to this point M, it was going up, right, up, and after that it is going down, okay. So the velocity component along y-axis before point M was increasing, okay, was positive, and after M that was negative, because now it is going down. It means that at point M velocity component should be 0, okay. And we also have noticed that if suppose you will throw some body upward, so it will go up and then it will go down. At certain point at its maximum height, its velocity would become 0. Similarly, at point M, its velocity component responsible for this projectile to go up and then downward, here in this case should be 0, okay, by the same reason, by the same logic. So at point M we have to find out what is the velocity at point M, and then try to find out its height. And then we know that v square minus u square is equal to 2as. That is the formula that we know, okay, where s is the distance, a is the acceleration, but we are interested in the velocity along y-axis, so that velocity should be along y-axis. Similarly, initial velocity should also be along y-axis. Similarly, acceleration should be along y-axis, and distance traveled along the y-axis, right? So that we know that the distance traveled by the body reach at M would be capital H. So here sy should be capital H. Ay we already know is minus g, right? Acceleration along y-axis is minus g because body is under the influence of the gravity alone. So ay is minus g, okay. And what is the velocity along y-axis at point M? That is 0, that we know. And the velocity, that is the initial velocity, that was u, that is this, that is the u sin theta. So you put all these values here and find out. So that is 0 minus u sin theta square 2, that is minus g, into sy is h, because that is positive, because body was going upward. So that was minus 2gh, and here it is minus u square sin square theta. So that h would be half, or you can write u square sin square theta divided by 2g, okay. So that is your maximum height attained. So here the basic logic we have applied here is that at maximum point the velocity should be 0 along the y-axis, okay. The vertical velocity should be 0. So that we had applied. Similarly, we will try to find out what is the range this projectile have. Range is the maximum horizontal distance that it will cover, right? So by the similar logic, you have to find what is the range. So for range, you have to apply this distance formula for x-axis, right, which is nothing but sx uxt plus half ax t square, okay. So what is sx? Sx is the total distance along x-axis, which is r. Ux is the u cos theta. Okay, t is the total time. Okay, plus half a x, we already have said ax is 0, t square nothing, so that would be 0. So your range would be u cos theta into t. Here this t is capital T. Suppose capital T is the total time taken, right? Cos theta. For time being, we will hold it here, and after finding the value of this total time capital T, we will put that value t here, and then we will try to find out what is the maximum r. But for that, we have to find out capital T, right? So that is the time of a projectile we have to find out. So time of a projectile. So again we will try to use this concept when the body has reached at point M. So if suppose we will say that the total time for that projectile when it has taken off its flight and then landed on the earth, that total time is capital T. So what is the time at M? So that logically should be half of that total time, because that was the time when it has traveled half of its distance, right? So so that is the total time. So we will try to find, and we know that what is h, that we know. Okay, so by applying that formula for h, okay, which is sy, we can find out value of t. So what is this that we have to find out? So what is sy first of all? So sy is here h, and sy is uyt plus half ay t square. Okay, that we know. So what is uy? Uy is u sin theta, and t that we have to know, plus half ay. Ay here is minus g, right, and t square, and that is h, right? So this would be u sin theta t minus half g t square h. But what is the value of h here? That we already have to find it out. The value of h here is u square sin square theta upon 2g. So you will put here this thing, u square sin square theta upon 2g is equal to u sin theta into t minus half g into t square. Well, this is a bit difficult to find the value of t here. So we again can find out this time here by using another formula. And what is this? That is v square minus u square equal to 2as. So that is not possible. So another is v is equal to u plus at. Okay, so here we know what is the velocity here. So velocity for y-axis, velocity along initial velocity along y-axis into ay into t. So here you can find out what is the velocity. So at that point M, the initial velocity, the velocity at point M along y-axis was 0, and that was u into sin theta, which was going upward, u into sin theta, and that was u cos theta, right? So you can put the value here. So what is this? Minus g into t. So that would be minus u sin theta minus g into t. So t would be here in this case u sin theta upon g. So by solving this equation, we will have the value for t, which is u sin theta upon g. Okay, but we can always find out by using a simpler method. So by using this formula, we can find the value of the t, but that t is only half of this. So what is the total time here? So total time of flight, which is t, is double of this small t. So that is nothing but 2u sin theta upon g. Okay, so by using this formula, we can find out the value of range, which we already have calculated. So this range would be u cos theta into t. So you can put this value here. So that is u cos theta into capital T, where this capital T is, capital T here is 2u sin theta upon g, and which is 2u square sin theta cos theta upon g, which is nothing but u square upon g, 2 sin theta and cos theta, and we know that 2 sin theta cos theta is nothing but sin 2 theta. So u square by g into sin 2 theta. So by that time we have calculated what is range, what is total time of flight of the projectile, and maximum height, that is the maximum height, right? Now there are some special cases that we can apply here. So what is one of the special case here is when theta is 0 degrees suppose. So what is range? So range here is u square by g, we have calculated sin 2 theta, right? So when theta is 0, so r would be u square upon g into sin 0. Sin 0 is always 0, so range is 0. So when theta is equal to 90 degree, so when theta is 90 degree, what is r? That is u square by g sin 90 into 2, that is 180 degree, which is again 0, that is 0, right? So when theta is what? 45 degree, what is your range then? Range is u square by g sin twice of 90, twice of 45, which is nothing but u square by g sin 90. Sin 90 is 1 effectively, so u square by g. This is the maximum value for a particular theta. So one can ask, what is maximum r for an angle, or you can say for what is the value of r which can be said as maximum when the angle is suppose 45 degree. That you have to prove that theta at suppose at angle 45 degree r is maximum. That suppose is you are trying to find. So r you know is u square upon g into sin 2 theta. So for that you have to differentiate this thing r, that is the method 1. For at first step 1, you have to differentiate d by d theta with respect to theta to r. So that would be d by d theta of u square by g into sin 2 theta. And what is this? That would be u square upon g, that would be, and then you have to differentiate this sin theta, so that would become cos 2 theta, and then differentiate 2 theta. So d by d theta of 2 theta, that is the chain rule, so that would become theta. So that is u square upon g cos 2 theta, and that would be 2 basically, so that is 2. Okay, that is the first thing. And then you have to for step second, you have to put this value as equal to 0, means d by d theta of r is equal to 0. So that would be 2 u square by g into cos 2 theta is equal to 0. It means that would be cos 2 theta is equal to 0. So when this cos theta is 0, so cos theta is 0 only when cos is 90 degree, right? So cos will cancel out, 2 theta is equal to 90 degree. So your theta should be 45 degree for this r to maximize, right? So that is the equation. So for r to be maximized or to maximum, theta should be 45 degree. So that is your solution. So for now we will wind up this thing. Thank you very much.